The next is interquartile range and quartile deviation. Now let us see what is this. Firstly, you should know what is interquartile range. Interquartile range is the range defined between different quartiles. So we have the difference of the third quartile minus the difference of first quartile. So it is defined as the difference in the upper quartile and the lower quartile, denoted by this Q3 and Q1. And quartile deviation, that is Q3 minus Q1 divided by 2. So this is the definition for quartile deviation. So that means we say this to be the average of interquartile range. So it is the semi means half, semi-interquartile range. Now you see, whatever is the given data, as in the case of weights, your data represent kg of weights, right? So your quartile would also have the unit of kg, and this also have the unit of kg, and when you subtract kg from kg, whatever is the answer, that would also be in kg. So this is also an absolute measure of dispersion. So that means it is represented in the same units as that of the given data. And the corresponding relative measure of dispersion without units, that is the coefficient of quartile deviation. So that is defined by this formula, Q3 minus Q1 divided by Q3 plus Q1. So these are the three formulas which are used for this second kind of dispersion. So first is the interquartile range, that is Q3 minus Q1. Second is the quartile deviation, that is Q3 minus Q1 divided by 2. And third is the quartile deviation, that is Q3 minus Q1 divided by Q3 plus Q1. So if you remember, what is this Q1 and Q3? So Q1 is the first quartile, and it is defined by the size of n plus 1 divided by 4th item in the when your given data has been arranged into the series, and Q3 is the size of 3 times n plus 1 divided by 4. So firstly you arrange your series in the ascending order. So whatever is the position that divides the series into quarters. So first quarter would be this, second quarter would be the median itself, third quarter is Q3. So here whatever is the number here, the data here, that would be Q1. Whatever is the data here would be Q2. Q2 is basically the median, so we do not use it. And whatever is the data here, that is Q3. So this is the third quartile and this is the first quartile. So this is clear, the formulas are clear. The next thing is we'll solve the questions using this formula. So the first question is, we are given this individual series 28, 18, 20, 24, 27, 30 and 15. So we are asked what is the interquartile range, what is the quartile deviation, and what is the coefficient of quartile deviation. So this is asked here. So the first task whenever we are given any kind of series is to arrange that series in ascending order. So that is done by keeping the smallest element first, and then the one greater than that, the one greater than that, and keep on doing it until we reach the last element. So here the total number of observations are, we have 1, 2, 3, 4, 5, 6 and 7. So n is 7 here. So now in order to calculate Q1 is nothing but the size of n plus 1 divided by 4th item. So what is n? N is 7. What is, so we'll substitute the value here. So we would have 7 plus 1 by 4, that is second item, the size of second item. What is second item here? The second item is this 18 number. It is not the index, but it is the item. So second item is this one, 18. So that is our first quartile, Q1. For the calculation of third quartile, we will look for the size of 3 into n plus 1 by 4th item. So n is 8. So when you substitute n to be 7 here, you would have 7 plus 1 by 4, that is 2. 2 into 3 is 6. So we'll look for 6th item. What is the 6th item here? 1, 2, 3, 4, 5 and 6. So the 6th item is this one, 28. So this is our Q3. Now we have Q1 and we have Q3. So our interquartile range would now be Q3 minus Q1. So it would be this 28 minus 18. So our answer is 10. This is the interquartile range. So now you see what is this interquartile range. Interquartile range is this range, the difference between Q3 and Q1. So this is the difference that we are calculating from here. So the quartile deviation is Q3 minus Q1 divided by 2. So it comes out to be 10 divided by 2, that is 5. And then the coefficient of quartile deviation, that is Q3 minus Q1 divided by Q3 plus Q1. So if we substitute the values, we will have this answer. So this is for the individual data. Now we have discrete series. For this discrete series, we are given wages in numbers, in rupees. So we are given rupees 10, rupees 20, 30, 40, 50 and 60. And we are given the number of workers obtaining these wages. So we have 2 workers which are having 10 as the wage, and then 8 workers having 20 wages, right? 20 having 30, 35 having 40, 42 having 50 and 20 having 60 rupees daily, right? So this is the daily wages that is given to you. So now they are asking, calculate the interquartile range and quartile deviation and the coefficient of quartile deviation from the following data. So first of all, you will calculate what is Q1 first quartile, and then you will calculate what is Q3. So how do you calculate this quartiles for discrete series? So for that, for wages, we create this column as X. So this is your wages. This is the frequency, that is the number of workers. And CF is the cumulative frequency. That means what you do, so these 2 columns would come as such, that is given to you in the question. For the cumulative frequency, now note here that 2 would be the same. The next quantity here would be the sum of this one and this one. So 8 plus 2 is 10. Next quantity would be 20 plus 10. So this would be 30, right? Next quantity would be 35 plus 30. So that would be 65. And so on. 42 plus 65 would be 107. 20 plus 107 is 127. So for cross checking, you see this is the total number of frequency that you will obtain. So this is same as this one. For cross checking, this should be same. So this is how you calculate cumulative frequency. That is, at every step you keep on adding the frequency of that particular step to it. So once you have cumulative frequency, so how will you calculate this first quartile? This is calculated by calculating the size of n plus 1 by 4th item. What is n? N is 127. So when you substitute 127 here, you get the size of 32th item. Now what would be 32th item? That you will see in cumulative frequency, this column. So 32 would come after 30. So that means it would be, the quartile range would be this quantity and not 30, because corresponding to this 30 we had this 30 over here. But because we are looking for Q1, that is the size of 32th item, 32th item would lie corresponding to this. So we have 40 as the first quartile. For the third quartile, we would look for 3 into n plus 1 by 4. So when you substitute n as 127, when you calculate, this comes out to be 96th item. So again you will go and look here in this cumulative frequency. So this is 65, this is 107. So 96 would lie here in between this two. So that means for the Q3 you will go for this particular row. Corresponding to this row, your Q3 would be 50. So this is your Q3 and this is your Q1. So your Q3 is 50. So we have Q1 and Q3. So now interquartile range is simply the difference. Quartile deviation is the average of or the semi-interquartile range. So this thing divided by 2, and the coefficient of quartile deviation using this relation is 0.11. Simple as that, right? And now we'll see for this continuous series. For this continuous series, what is the interquartile range, what is the quartile deviation, and the coefficient of quartile deviation for the following data. So now you see your series is given to be, your data is given to be ages in years. So that is 0 to 20, 20 to 40, 40 to 60, 60 to 80, 80 to 100. So now you see this quantity and this quantity is the same. So that means you are given exclusive series. So we do not have to worry about changing this to exclusive series because it itself is an exclusive series. And the persons which are lying within this particular range is 4. So this is the corresponding frequency. Number here is 10, 15, 20 and 11. So for that, what we do, we again calculate the cumulative frequency first. So age as such as given in the question, F as such as given in the question. This F is the person. So what would be CF? CF is 4 as such. Then 4 plus 10 is 14. Then 15 plus 14 would be 29. 20 plus 29 would be 49. 11 plus 49 is 60. So now this quantity matches with this one. That means we do not have any calculation mistake. So now for the first quartile, what we'll do, we'll see it n by 4. Now because n here is even, that is 60. So we'll use this formula n by 4. And because in the previous two cases we had our n that was odd. So this n was odd. So that is why we have used this formula n plus 1 by 4th item. So now in this question we will see the n by 4th item. So that would be 60 by 4. That means we go and look for what is the 15th item present in our series. So 15th item would come just after this 14 here. So corresponding to this, our quartile will lie in this particular range. So what would be this? This would be 40. This would not be 40. This class would be the quartile class. So for this we will use this particular formula. So you have to remember this formula. What is the formula? Formula says the first quartile is given by L1. That means the lower value of the class. What is the lower value? Our class here is 40 to 60. So the lower value is this 40. So we have the value of L1 as 40 here. N by 4 is 15. So that is simply 15. And what is CF? CF would be taken as the cumulative frequency of the preceding class. So here, because for Q1 this was our quartile class, therefore CF is this quantity that is taken from the previous class. So this is our CF. What is F? F would be corresponding to the same class. So it would be 15 into I. What is I? I is the difference between the upper value and the lower value, right? So upper value minus lower value, that would be 20. So I here is the interval length. This is the interval length. So its value is 20. So when you substitute all these values and calculate, your answers comes out to be 41.33. So that is Q1. So next for Q3, we again go and look for this quantity 3n by 4. Instead of 3n plus 1 by 4, we have 3n by 4, which comes out to be 45th item. So again we go and look for CF having value greater than 45. So greater than 45 is this one. So that means 60 to 80, this class interval would be the range in which our Q3 will lie. So we'll use again the same formula, L1 plus 3n by 4 minus CF divided by F into I. So L1 is here 60, the lower value of the class interval. 3n by 4 is 45, we have just calculated. CF would be the cumulative frequency of the preceding class. So it would be 29. So it would be 29 here, and then the frequency of the same class, that would be 20. So this is 20, and then I is the interval length, that is 20. So when you substitute all the values, you have the value of Q3 as 76. So once you have Q3, once you have Q1, you would have the interquartile range and quartile deviation as Q3 minus Q1 and Q3 minus Q1 by 2. So this is the interquartile range, this is the quartile deviation, and the coefficient of quartile deviation is 0.29. This is simple calculation. So now next let us discuss the merits and demerits for quartile deviation. So the merits of quartile deviation are, you saw that this is very simple to compute and easy to understand, right? It is less affected by extreme values because here we have to calculate Q1 and Q3, so they are not directly dependent upon the extreme values as in the previous case. So this is the merit for this one. Moreover, it can be computed in open-end interval classes. What do you mean by open-end interval classes? For example, your data is like this. The data shows the marks of students. So the students having marks less than 10, and then marks 20, and then 30, and then 40, and then marks greater than 40. So here your data is open-ended data because here we have not mentioned from where to where we are going, and here also we have not mentioned greater than 40 means how much greater. So we have not mentioned that. So you saw this is the open-end cases. So here it can be computed for open-ended cases because we are not considered with this the end points, but we are considered with this quartile Q1 and Q3. So that is why this is easy to compute for open-ended classes as well. This is superior and more reliable than range. It give you more better results. However, you see, it is useful when dispersion of middle 50% items is calculated. So if you see this range of this interquartile range. So what is this range? So your complete data was this one. So your complete data was from here to here. But now you are calculating the interquartile range from here to here only. So that means you are only considering this 50% of the data, middle 50% of the data. So if that is required, then this becomes a merit. But if that is not required, then we have this to be the demerit because it only compares the 50% items of the given data. Further, it is not capable of any algebraic treatment. It is affected by sampling fluctuations. Once you change your data, your quartile deviation would change. Moreover, this is not a good measure of variation.